Hello, students. Now we'll start with our fifth module of the course Fundamentals of Artificial Intelligence. So, our fifth module talks about the learning concepts. That is, we all know that every human learns in different ways, right? A child memorizes multiplication tables, a driver learns from an instructor, and also a student learns by solving problems, and also a doctor learns from past cases. Likewise, AI systems also learn in similar ways. Okay? So, in this module, we will study different types of learning methods used in artificial intelligence. Okay? So the learning concepts include rote learning, learning by taking advice, learning by problem solving, learning from examples like decision trees, then ensemble learning, explanation based learning, and then finally reinforcement learning, which is categorized into two, that is passive reinforcement learning and active reinforcement learning. And finally, we will conclude our fifth module with introduction to natural language processing. So now, what is learning? The act, process, or experience of gaining knowledge or skill. So in the terms of system, you can tell like learning is the process by which a system improves its performance over time based on the experience. So in artificial intelligence, learning means a program which can modify knowledge or behavior using the historical data, feedback, or the interaction. So a system that learns should perform better tomorrow than it did today. So it can be tell us behavioral modification, especially through the experience or condition. So for example, if you're considering a real life example, like thinking of learning to ride a bicycle, okay, on the day one, you will fall. And what about day two? You balance slightly. After several attempts, you ride smoothly. Likewise, your performance improves because of the experience, right? So, this is the type of learning. Similarly, in an AI system, it improves after processing more data or solving more and more problems. Learning denotes changes in the system that are adaptive in the sense that they enable the system to do the same task or tasks drawn from the same population more efficiently and more effectively the next time. The other definition of learning is that agents can improve their performance through diligent study of their own experiences. So we can tell like learning is a process by which a system improves its performance through several experience. Human learns continuously from our day-to-day activities, right? And intelligent machines are designed to do something similar which human do. For example, if you're considering a small child, when a child first learns to write, the letters will be like uneven and shaky. After repeated practices, of writing, the handwriting becomes neat and consistent, right? The improvement happens because of the experience, because of the past experiences. So, similarly, in artificial intelligence, a system learns when it becomes better at a task after processing the data or interacting with its surroundings. So, learning may involve acquiring new knowledge and also refining existing knowledge, or you can tell like reorganizing information so that it can be used more effectively in the future. So, learning is self modification that results in beneficial changes to the behavior. Some questions like, can machines learn? If you program a computer, has it learned anything? If you add data to a database, is it learning? These are some of the questions which will pop in our mind, right? From an AI perspective, learning transforms raw information into some meaningful knowledge. Consider how we learn to recognize people. At first, you may not recognize a new colleague, right, or your new friend. But after seeing them several times, your brain identifies their face instantly. And then you have learned the pattern of a phase. So in the same way, AI systems analyze data repeatedly until they detect useful patterns. These patterns allow them to make some predictions or some behaviors or some decisions. So you can tell like learning can be explicit where instructions are given directly or implicit where the system discovers patterns of its own. And a main key property of learning is generalization. If you learn to drive a car, you can usually drive another car without starting from zero, right? This ability to apply knowledge to a new situation is what makes the learning more powerful. Now we'll see the different methods of learning. There are mainly four types or four methods of learning. First one is rote learning. Second one is learning by taking advice. Next one is learning from problem solving experience. And then next is learning from examples. So different situations require different ways of learning. Sometimes memorization is enough. In some cases, reasoning or experimenting is required, such as if you want to solve a puzzle or if you want to design a project. Okay, and therefore, artificial intelligence includes multiple learning methods, each suited for specific task. So, if you are choosing the right method, this right method depends on the nature of the problem, the availability of the data, and the desired outcomes. From this section onwards, we will explore more important learning approaches which is used in AI. So, as we discussed in this slide, we have four types of learning. That is rote learning, learning by taking advice, learning from problem-solving experience, and learning from examples. So, first one is rote learning. That is simple storage of computed information. Next one is learning by taking advice. This is very similar to rote learning, but in some cases, advice is needed to operate. Whereas in the case of learning from problem solving experience, remembering effective structures and methods which helped in solving the previous problems. Learning from examples usually involves a teacher who helps to classify things. So now if we are taking an example of a computer, so when a computer stores a piece of data, it is performing a form of learning. Okay. In case of data caching, we store computed values so that we do not have to recompute them later. That will be preserved in the cache. Then, when computation is more expensive than recall, this strategy can save a significant amount of time. So, has been used in AI programs to produce some surprising performance improvement. So, this type of caching is known as rote learning. It shows the need for some capabilities required of complex learning systems such as organized storage of information and generalization. Now we'll see organized storage of information and generalization. So organized storage of information means in order to improve the performance and speed up to use the stored value than it would be to recompute it. Then there must be a special technique that accesses the stored value quickly, like that of data cache. Generalization is here the number of distinct objects that stores are very large, so that to keep the number of stored object manageable level, some kind of generalization technique is necessary. So you can tell like rote learning is the simplest form of learning. In our day-to-day life, rote learning occurs when we memorize information without understanding the reason behind it. So for example, if you're considering memorizing multiplication tables, many of us can recite that 7 times 8 equals 56, but we don't know what is the exact reason behind that, right? So another example is remembering a phone number or a Wi-Fi password. You simply store the information and recall it whenever you need that. Likewise, in artificial intelligence, rote learning means storing solutions exactly as they are encountered and retrieving them when the same situation occurs again and again. So you can tell like rote learning is very fast and very easy to implement, but if there is any changes in the problem, the stored solution may no longer work. Next type of learning is learning by taking advice. So this type is the easiest and another way of learning. In this type of learning, if you're considering a programmer writes a program to give some instructions in order to perform a task to the computer. Once it is learned, the system will be able to do new things. Also, there can be several sources for taking advice, such as humans, internet, etc. Okay, even though that person is doing the coding, he or she can take the advice from different types of sources. This type of learning has a more necessity of inference than rote learning. Okay, so learning by taking advice mainly involves acquiring the knowledge from different external sources. If you are considering humans rely heavily on advice, right? For example, a beginner driver learns from an instructor who explains when to change the gears and how to use the mirrors and how to handle the traffic. And also, if you're considering another example, like a patient follows a doctor's advice regarding the medication and what are the changes he or she should be change in their lifestyle. Likewise, in artificial intelligence, a system can receive guidance from the experts or the manuals or the different predefined rules. The challenge is converting that advice into what instructions, okay, that the system can execute. So this method is faster method because the system benefits from prior human knowledge instead of which is discovering everything independently. As the stored knowledge in the knowledge base gets transformed into an operational form, the reliability of the knowledge sources always taken into consideration. Okay. For instance, someone might advise drive slowly in the rain. A human understands this naturally, but a machine must translate it into measurable actions, right? Such as it should reduce the speed when the rain is detected. Advice may also be incomplete, and different experts will provide different types of recommendations. Therefore, systems that learn from the advice must interpret, organize, and sometimes evaluate the reliability of the information before applying it. The next type of learning is learning in problem solving. So learning in problem takes various technique to improve the performance, like that problem solver solved the problem by taking advice from someone else or the teacher. So learning in problem solving occurs when experience from the past problems improves future performance. For example, if you're considering you are solving a mathematics exercises, okay, the first time you encounter a complex problem it may take so long, right? After practicing the similar problems in a different method, you develop strategies that make future solutions very strong, right? And if you're considering another example, like if you're assembling furniture, the first attempt will be very confusing, right? But subsequent assemblies become easier because you remember the steps based on the previous attempts. So similarly, in artificial intelligence, systems adjust parameters in order to emphasize the factors that lead to the successful outcomes. So that is what learning by parameter adjustment. The most important question in the design of learning program based on the parameter adjustment is that when the value of parameter increased and when the value of parameter decreased, what will happen? The second question is how much should the value be changed? Hence, the answer to the first question is that the value of parameter that predicted the final outcome accurately should be increased, while the value of parameter per predictor should be decreased. in designing the program, we have to know a priority, how much weight should be the attached to each feature being used. So in artificial intelligence, as we already discussed, systems adjust the parameters in order to emphasize the factors which lead to the successful outcomes or the successful outputs. This gradual adjustment will help the system converge toward the better solution in the next time. Next type of learning is learning with macro operators. So macro operators is consisting of sequence of action performed in semantic way. A macro is just like a regular operator except that it consisting of sequence of action, not just a single one. So macro operators you can tell like are the combinations of different steps treated as a single action. So if you're considering an example of a human behavior, many skills become an automated through practice. For example, when learning to type, beginners will look at the keyboard and press each key carefully. Whereas experienced typists, what will they do? They produce entire words almost automatically. Similarly, when we are driving an experienced driver, what will they do? They perform gear shifting, steering, and accelerating seamlessly without thinking about each and every action separately. In artificial intelligence also, frequently occurring sequence of operations can be grouped into macros. So using a macro allows the system to perform complex procedures very quickly and it will reduce computational effort. Suppose we are given with a initial uh, block word situation in which on C comma B and on A comma table both are true. This we already saw in our previous module, that is goal stack planning. And the same example is repeated over here. The strips can achieve the goal on A, B by dividing a plan with a four-step: unstack C, B, put down C, pick up A, stack A, B. Hence, in order to solve a problem, it is better to define certain macro operation in the problem. For example, in this case, you have four macro operation, that is unstack C, B, put down, pick up, and stack. So a macro operation is a precondition, which are the initial conditions of the problem just solved, and the post conditions are correspond to the goal just achieved. Next type of learning is learning by chunking. Chunking is a process similar in flavor to macro operators. The idea of chunking comes from psychological literature on memory and problem solving. So chunking involves mainly grouping related elements into meaningful units. For example, if you are remembering a long number, instead of memorizing 10 individual digits, what we'll do? We will divide it into smaller groups, making it easier to remember. So another example is that if you are doing reading, skilled readers, what will they do? They will recognize whole words rather than processing individual letters one by one. So in the case of artificial intelligence system also, chunking stores frequently used information patterns as single units. This reduces memory load and also it speed up processing because the system can retrieve one chunk instead of many separate elements. So chunking improves efficiency both in the memory usage and solving of the problem. So that mainly solving the problem, we have to define the number of production in the memory. Depending upon the problem, we call chunk from memory and solve the problem. So learning by chunking means it groups related elements into meaningful units. So next is a general purpose problem solving system, or it can be stated as the utility problem. So Prodigy is the general purpose problem solving system that incorporates several different learning mechanisms. A good deal of the learning in Prodigy is directed at automatically constructing a set of control rule in order to improve the search in the particular domain. If you want to improve a search in a particular area or particular field, there will be a set of control rules, and that rules will be constructed automatically with the help of Prodigy. So Prodigy can acquire control rules in number of ways, that is through mainly through three methods, that is through hand coding by programmer, through a statistic analysis of the domain operators, or through looking at traces of its own problem solving behavior. So Prodigy learns control rules from its experience. The major work in Prodigy was the identification of utility problem in the learning system. It maintains a utility measure for each control rule. So, as the system learns more and more, it accumulates a large amount of knowledge. However, not all the knowledge remains useful, right? So, in everyday life, we also filter each and every information. For example, if we are preparing for an exam, we will focus mainly on the important topics rather than what reviewing each and every topic which was handled throughout the semester. And also in AI, this challenge is known as the utility problem. That is, the system must determine which learned rules are beneficial and which should be ignored or removed. Similarly, in our example also, we will filter out only the important topics and we will ignore some of the topics. Likewise, the system also do. So some system assign a usefulness score to each rule based on its contribution to performance. This ensures that the knowledge base remains efficient and relevant. Now we'll see more about the learning concept in our next video. Thank you.